Page 70, problem number 59 reads, find the inverse function of f. So for given f of x equals 2x minus 3, we need to find the inverse of this function. Well, another way I can think about this is to write as y equals 2x minus 3. Now, the inverse of any point we can get by just switching the x and y values. So the inverse of a function we can get by switching the x and y values. So let's do that. Let's switch around the x and the y. Well, that'll give me x equals 2y minus 3. And now if I solve this for y, I'll have the inverse function. So if I add 3 to both sides, that gives me x plus 3 equals 2y. And then if I divide both sides by 2, I get y equals x plus 3 divided by 2. And I can write that 1/2 x plus 3 halves if I choose, or I can leave it as is. But I should probably write it in this format and say the inverse of f of x is equal to x plus 3 over 2. Now I can check my work by getting my calculator out, and let's go and graph both of these functions. So my first one, y equals 2x minus 3. And my second one, y equals, I'm going to put my numerator in parentheses, x plus 3. We'll close that, divided by 2. Now when I graph these, notice my first graph's a line, second graph is a line. We should see that these graphs are reflections of each other across the line y equals x, so across this diagonal line. And you can see if you could flip that first graph across this diagonal line, it's going to give you that second graph. So yes, indeed, these two functions are inverse functions of each other.